Hello guys, my name is Omar and I'm going to be explaining to you what the ideal gas law is composed of. If you take Boyle's law, Charles' law, Avogadro's law, and combine these three formulas, you're going to end up with the ideal gas law. The ideal gas law is PV equals nRT, where P is the pressure, V is the volume, N equals the number of moles, R, which is the gas constant, and T is the temperature. Now, the ideal gas law is a physical law describing the relationship of measurable properties. Now that I briefly explained this to you guys, I'm going to go over to my colleagues to further help you guys understand what the ideal gas law is about.
A car tire of 10.2 liters is filled with 0.504 moles of a gas at a temperature of 15 degrees Celsius. What is the pressure of the tire? Convert from ATM to PSI.
To initiate my problem, the first thing I did was I color-coded all my variables. For N, I used red. For temperature, I used blue. And for volume, I used green. And my R just remains constant. Second, what I did was change my PV equals nRT to P equals nRT divided by V because we are solving for the pressure. Next, I changed my Celsius to Kelvin and I did 15 plus 273. That gave me 288 Kelvin. Then furthermore, I plugged in all my variables. So I initiated with P equals my moles, 0.504 moles. Then the next thing I did was, since we are using liters, I used 0.0821 L ATM. Then the next thing I did was I also added my 288, and then I divided that by 10.2 liters, which is my volume. And then once I plugged in all those numbers, my pressure was 1.168 ATM. And then we are converting from ATM to PSI, so we need to do some dimensional analysis. 14.7 PSI equals 1 ATM. So then I did 1.168 ATM times 14.7 PSI divided by 1 ATM, and that gave me 17.169 PSI, and I furthermore round that up and I get 17 PSI.
Our everyday example, the ideal gas law states that change in pressure is directly proportional to the change in temperature, or absolute temperature, which we can relate to during the winter when reduction of tire decreases in pressure and temp.
Overall, my colleagues explained to you what the ideal gas law is. They gave you the definition and a visual example of how it relates to a real-world problem.